In this example, we're going to sketch a graph of the function f of t equals 2 sine pi t minus pi over 4 minus 3. To accomplish this, what we're going to want to do is determine what the midline is, what the amplitude is, what the horizontal shift is, and what the period is. Starting at the top, we can determine the midline by noticing that this function has a minus 3 here on the outside of the function. That minus 3 will cause the sine wave to be shifted down 3 units, resulting in a midline of y equals negative 3. The amplitude can be determined by this number 2 that's on the outside of the function. That number will cause a vertical stretch by a factor of 2, resulting in an amplitude of 2 units. To determine the horizontal shift, we're going to need to adjust the format of the function slightly. We'll need to adjust the input value here and factor pi off of that term. So what I'll do is I'll rewrite this function f of t as 2 sine pi, and I'll factor pi off of the term inside the sine wave, and then realize I'll need t minus 1/4, which we can sort of double check here by recognizing that if you multiply pi times t, you'll get pi t, and if you multiply pi times 1/4, you'll get pi over 4. So all we've done is really kind of reorganize the function, but it's still the same as it was before. But the advantage of this version of the function is that we can see what the horizontal shift is, namely that it's this number 1/4. And since there's a minus in front of it, that suggests that there's been a shift 1/4 unit to the right. Okay, finally we'll need to determine the period. The period comes from two features of the graph of the formula. The first is that the sine function is used, and the sine function has a period of 2 pi. And then the next issue is that there's a number pi in here, and that number pi is causes a horizontal stretch that distorts the period. And so to determine the period of our function, we'll start with the period of sine, which is 2 pi, and then have that period of sine be stretched or compressed by a factor of 1 over pi. And when we perform that calculation, we realize that the period is 2 units. Okay, now that we have these 4 features of the graph, we can draw it. But first we'll want to get some scale on the axes. The horizontal shift and the period suggest to us what sort of scale is appropriate for the horizontal axis. And in order to clearly label exactly where 1/4 of a unit shift to the right is, we're going to need to use multiples of 1/4 as our tick values. And so I'll label the very first tick here as 1/4, and then double this, triple this, etc. as I go. So 1/4, 2/4, which is 1/2, 3/4, 4/4, which is 1, 5/4, 6/4, which is 3 over 2, 7/4, 8/4, which is 2, 9/4, 10/4, which is 5 over 2. And we may want to put a tick or two towards the negative direction. And then we can use the midline and amplitude to get a sense of what would be appropriate on the y-axis scale. Since the midline is -3, we definitely need a tick labeled at -3. Considering the amplitude is 2 units, you can tell that a nice simple scale of 1, 2, 3, 4 going up, and -1, -2, -3, -4, -5, -6 going down the y-axis should work nicely for this graph. Okay, so now what we can do is go ahead and label our midline. The midline's y equals -3, so we can go ahead and just draw a horizontal line at y equals -3. Okay, and although it's not a feature of the graph exactly, we can give ourselves a hint at where the the amplitude is by drawing another pair of horizontal lines 2 units up above where the midline is and 2 units below where the midline is. So we'll know we're going to want to sort of bounce our sinusoidal wave between those very faint orange dotted lines. Okay, now we're ready to take advantage of the horizontal shift. So we need to shift our wave 1/4 unit to the right, and this is a sine wave. And the sine wave usually behaves, it crosses through the midline at the origin and comes up out of that midline. Now we're going to want to make that behavior happen 1/4 unit to the right. So if we go ahead and draw a dot on the midline at 1/4 unit, and keep in mind that we're going to want to come up out of that midline to produce our sine wave. We should be in good place to draw our graph. Now, since the period is 2 units, we can predict that 2 units after 1/4 unit, at 2 1/4 units, or 9/4 units, we should have completed a full period. Halfway between these two dots, we should have completed half of a period, and the sine wave crosses through the midline at half of a period. And now we can label dots at 1/4 of a period. We know that the sine wave reaches its maximum after 1/4 of a period, and after 3/4 of a period it reaches its minimum. So we can label those 5 key dots so that we have a good chance of getting an accurate graph. And now we can just connect those dots, and what I prefer to do is to draw the sine wave 1/4 period at a time, connecting one pair of dots with a reasonably shaped curve, and then the next pair of dots with a reasonably shaped curve, and then the next pair of dots, and the next pair of dots. It doesn't produce a perfect graph, but it helps me have some kind of control over the curvature of the graph, and make sure I hit those key dots correctly. And then one last thing we're going to want to make sure we do, which is to draw arrows on the ends of our graph to impress on our readers that this graph doesn't end at those solid dots. Instead, it's got a domain of all real numbers, so it continues forever in both directions.